All right, so today we are going to be taking a deep dive into data privacy and compliance. And this is something that's super important for all you software designers and architects and anyone who's a security manager and auditor out there.
Yeah.
We've got some really cool material here today, all about a tool called Pdiver and how it's addressing the whole issue of keeping sensitive data safe in logs.
Yeah, and what's interesting is that logs are essential, right, for things like troubleshooting and, keeping an eye on your systems, but they can also be a huge vulnerability if you don't handle them carefully.
It's almost like this balancing act, right? You absolutely need the visibility that logs give you, but you can't afford to just expose all this PII and PHI. I mean, nobody wants to deal with those breaches or regulatory violations, right?
Yeah.
And that's where Pdiver comes in. It's built to kind of transform that sensitive data while still letting your logs do their job.
Yeah, exactly. It's not just about getting rid of logs altogether. It's about making them safer to use without losing all that useful information. And that's a big deal for any organization that's, trying to manage risk effectively.
So today we're going to take a look at how Pdiver helps you achieve that balance, making it easier to protect the data in your systems. We'll be looking at stuff like how easy it is to use, how it handles high performance demands, different ways you can customize it, and all the different integration patterns that make it so versatile.
And of course, we can't forget about the flexible deployment options, because let's be real, one size rarely fits all in software. Different environments have different needs, and Pdiver seems to get that.
Yeah, and the material we have today really stresses how hard it is to keep logs secure. They even talk about how those seemingly harmless debugging practices can expose sensitive data.
Yeah, it's you need those detailed logs to actually find and fix problems, but then those same details can come back and bite you if they end up in the wrong hands.
It's a real catch-22. And then you've got the whole rise of decentralized logging, which is great for getting insights, but it also means there's more places where attacks can happen with all those logs scattered all over different systems.
I mean, imagine you're a company with a ton of microservices, each one spitting out its own logs. Trying to secure that kind of environment, it gets complicated really fast.
Yeah, and they were pretty upfront about logs being prime targets for attackers. I mean, they have so much info about your systems, user behavior, and of course all that sensitive data that attackers are after.
It's a good reminder that security is an ongoing thing, not a one-time fix, and logs are often a weak spot. So having the right tools and strategies to protect them is really important.
Okay, so we've talked about the problem. Logs are both important and risky. So let's talk about how Pdiver tackles these challenges, starting with something that I think everyone is concerned about, especially if you're on a busy team, and that's ease of use.
Yeah. The docs really stress Pdiver's zero-touch automation and how intuitive it is to configure. It's designed to keep maintenance overhead super low, which is a huge plus for teams that are already stretched thin.
So it's not like a tool that needs constant attention or a whole dedicated team to manage.
Exactly. The idea is that once it's set up, it just kind of runs in the background, automatically protecting data without needing someone to step in all the time. And that frees up people to focus on other important stuff.
That sounds like a dream for any security manager or, overworked developer.
Yeah.
Now, I'm curious about Pdiver's performance. Everything is about speed these days, and systems that can't keep up get left behind. So how does Pdiver handle those high-performance demands, especially in systems that need real-time data?
That's where Pdiver's architecture really comes in. The documentation highlights that it can process data with millisecond level latency, which is super important for things like financial platforms or IoT stuff, where even tiny delays can cause problems.
So we're talking fractions of a second here, right? How does it get that fast?
Well, it's built with a scalable architecture that can handle even really heavy loads without performance taking a hit. There's a big emphasis on avoiding bottlenecks.
So it's not just about processing data fast, but doing it consistently and reliably, even when there's a ton of data flying around. That's impressive.
It's a must-have for anyone working on mission-critical systems where performance is king.
Now, one thing we all know is that no two systems are exactly alike, and that means different approaches to data privacy are needed. So how does Pdiver handle that?
Well, Pdiver is really customizable. The documentation goes into its flexible data handling, using external parameters and context-aware transformations.
Context-aware transformations, that's interesting. Can you give us an example?
Sure. So imagine you need to protect social security numbers, right? In a development environment, you might want to completely mask them. But in an analytics pipeline, you still need to see patterns, so you might choose to keep hashed values. Pdiver lets you set up these different rules based on the context, so data is protected the right way for each use case.
That's pretty clever. So it's not just a one-size-fits-all approach to masking data. It gives you control over how much protection is needed depending on the environment or system.
Exactly.
Okay, let's talk about something that's especially relevant for software designers and architects, integration patterns. How does Pdiver fit into different system architectures and workflows?
That's where Pdiver's integration patterns come in. The documentation talks about 4 main ones: runtime, active runtime, passive static, and then hybrid combinations of those. They give you a lot of flexibility in how you actually use Pdiver in your systems.
Okay, that sounds promising. Can we break those down a bit? Yeah. I'm especially interested in how they handle the different ways that logs are generated and managed.
Sure. So let's start with runtime active Pdiving. Yeah. This one's all about intercepting the data as it's being generated in flight. It's like a security checkpoint right at the source.
So as a software architect, if I was designing a system that needed real-time data processing, I could use runtime active Pdiving to make sure sensitive data is transformed before it even hits the logging system.
Exactly. It's perfect for things like API gateways, message queues, anything where data is constantly moving. Pdiver sits right in that flow and transforms sensitive stuff on the fly.
That sounds super powerful, especially for systems that need those immediate privacy safeguards. What about systems that work with data that's already there, like in a database or logs that are already generated?
That's where runtime passive Pdiving comes in. It works more behind the scenes, processing data in batches and applying transformations before it's sent to its final destination, like long-term storage or another system.
So a security manager who's dealing with a huge database full of sensitive customer info, they could use runtime passive Pdiving to make sure the data is properly anonymized before it's archived or used for analytics.
Absolutely. It's a bit more subtle than the active approach, but it's just as effective. And it's really good for those cases where you don't want to mess with the existing systems too much.
Now, we've talked about active and passive, both of which seem to deal with data that's being actively used or created. But what about historical data, like archived logs? How does Pdiver deal with that?
That's where the static integration pattern fits in. It's specifically for data sets that are already stored, whether it's archived logs, backups, that kind of thing.
So if I was an auditor and needed to look at logs for compliance reasons, I could use static Pdiving to transform any sensitive info in those logs before I start my analysis.
Exactly. Static Pdiving gives you that flexibility to work with those big static data sets without impacting the performance of your live systems. It's also useful for things like testing or staging environments where you don't necessarily want to be using real sensitive data.
That makes a lot of sense. Now, the last one you mentioned was hybrid combinations. What does that actually mean, and why would you want to do that?
Hybrid combinations are all about being flexible and customizing things. Because let's face it, not every system is going to fit perfectly into one category. So with hybrid combinations, you can take bits and pieces from runtime, active runtime, passive, and static, and put together a solution that fits your exact needs.
So, for example, a software designer could use runtime active Pdiving to protect sensitive data in real-time API calls, but also use runtime passive Pdiving to anonymize data before it's written to a database.
Exactly. It's about using the right tool for the job and realizing that different parts of your system might need different approaches to data privacy.
Okay, that's a really interesting concept. It speaks to needing tools that can adapt in these complex software environments we have today. Now let's talk about deployment options. Our listeners are working in all sorts of environments, from servers they manage themselves to cloud platforms. How does Pdiver handle that?
Pdiver is designed to be infrastructure agnostic, so it can be deployed on premises in the cloud or even in hybrid environments, and it behaves the same way no matter what. The documentation highlights that it works with platforms like AWS, Azure, Kubernetes, you name it.
So it doesn't matter if I'm running a more traditional setup or if I've gone all in on the cloud. I can still use Pdiver to protect sensitive data in my logs.
Exactly. Pdiver adapts to your environment. You don't have to adapt to it. That flexibility is really important for organizations that are moving to the cloud, or for those that have a mix of on-premise and cloud-based systems.
Being able to adapt like that is super important in tech these days. Things change so fast. Now, I think our listeners are going to want to hear about some real-world applications of these integration patterns. Can you give us some concrete examples of how Pdiver can be used to protect logs in different situations?
Yeah, definitely. The Documentation has some good use cases that show how versatile Pdiver's integration patterns are. Let's start with something that a lot of our listeners will probably encounter: transforming local log files.
That's a basic use case for pretty much any software system. How would Pdiver be used there?
Well, all three integration patterns, runtime, active runtime, passive, and static, can be used to protect sensitive info in local log files.
So a software developer working on an app that generates logs locally, they have options for making sure those logs don't contain sensitive data.
Yep. With runtime active Pdiving, you could integrate Pdiver directly into the app's logging framework, so that sensitive info is transformed before it's even written to the log file.
That sounds like a really proactive approach to data protection. What about runtime passive Pdiving? How would that work?
Runtime passive Pdiving would mean deploying Pdiver as a separate process or service. It would scan the log files regularly and apply transformations to any sensitive data it finds.
So it's more of a background process, cleaning up sensitive info after the logs have been created.
Exactly. It's a less intrusive approach that might be better in situations where real-time transformation isn't necessary.
And what about static Pdiving? How would that be used for local log files?
Static Pdiving would be perfect for when you need to clean up archived log files or historical data that's not being generated anymore. You could use Pdiver to scan those files and apply transformations to any sensitive info they contain.
So it's a way to make sure that even older logs, which might not be subject to the same security scrutiny as active logs, are still compliant with data privacy regulations.
Exactly. Static Pdiving is really useful for maintaining data privacy over the long haul.
Okay, let's move on to another common scenario: handling logs in a centralized storage system. A lot of organizations use centralized logging systems like Elasticsearch to gather logs from multiple places. How does Pdiver fit into that?
Again, all three integration patterns can be used to protect sensitive info in centralized logging systems. With runtime active Pdiving, you could integrate Pdiver directly into the logging agents or applications that are sending data to that central system.
So sensitive info would be transformed before it even gets to the central repository.
Yep, that approach provides really strong protection because sensitive data never even enters the centralized system in the first place.
And how would runtime passive Pdiving work in a centralized logging environment?
You could deploy Pdiver as a separate service or component within the centralized logging system itself. It would process incoming logs, apply transformations to any sensitive data, and then store the cleaned up logs.
So it acts like a filter, making sure only sanitized data is actually stored in the central repository.
Exactly.
And what about static Pdiving?
With static Pdiving, you could use it to regularly scan the data in the centralized system, apply transformations to any sensitive info that wasn't caught by the runtime mechanisms, and just make sure everything stays compliant.
So there's like a double check to make sure all the data in the central repository, no matter when it was added, is properly protected.
Exactly. Static Pdiving adds an extra layer of security by catching any sensitive data that might have slipped through.
Now, the last scenario I want to talk about is cloud environments, which are becoming more and more common. How does Pdiver handle the unique challenges of protecting logs in cloud platforms like AWS?
Pdiver's infrastructure agnostic design makes it a good fit for cloud environments. It can be deployed as a service or integrated with different cloud-native components like AWS Lambda functions or Azure functions.
So it works well with the tools and services that our listeners are already using in their cloud environments.
Yep, you can use Pdiver's capabilities without having to redesign your systems or change how you do logging.
Can you give us some specific examples of how the integration patterns would be used in a cloud setting?
Sure, let's say you're using AWS CloudWatch to collect and monitor logs from your apps. With runtime active Pdiving, you could integrate Pdiver right into the CloudWatch agent. That way, sensitive info is transformed before it's even sent to CloudWatch.
So it's basically intercepting the log stream at the source.
Right, it gives you real-time protection because sensitive data never reaches the cloud logging service. With runtime passive Pdiving, you could deploy Pdiver as a separate Lambda function. It would process logs from CloudWatch logs and apply transformations before saving them somewhere secure, like an encrypted S3 bucket.
So it's like a post-processing step, making sure data is cleaned up before it's stored long-term.
Exactly. And with static Pdiving, you could use it to scan your S3 buckets or other cloud storage regularly, just to make sure any old logs or archive data are also free of sensitive info.
So it helps you maintain data privacy compliance across your whole cloud infrastructure, even for data that's not being actively generated.
Exactly. Pdiver's flexibility and how well it adapts makes it a really valuable tool for protecting sensitive info in cloud environments.
I'm sure our listeners are wondering how to pick the right integration pattern for their needs. Is there an easy way to decide which approach is best?
There's not really a one-size-fits-all answer, but the documentation does have some guidance on choosing the right pattern based on what you need and what your priorities are.
So it's about understanding the trade-offs and making sure the pattern you choose aligns with what your organization is trying to achieve.
Exactly. Let's dig into those decision-making factors in the last part of our deep dive.
Okay, so welcome back everyone. We've been talking all about Pdiver and how it helps you protect sensitive data in logs. We've gone over why unprotected logs are risky, and we've even gotten into the specifics of how Pdiver integrates with different systems and how you can deploy it.
Yeah, and now we're going to get practical. How do you actually pick the right Pdiver integration pattern for your needs?
That's the question, right? Luckily, our sources give some good advice on how to make that decision. It really comes down to matching the pattern to what your organization cares about, how sensitive the data is, and the specific needs of your systems.
Okay, so let's look at the main things to think about for each pattern. Starting with runtime active Pdiving. This one's the best choice if you need protection right away. If your logs have super sensitive data that could be seen by outside systems or attackers, runtime active Pdiving is the way to go.
So like if you're a bank and you're processing transactions in real time, you could use runtime active Pdiving to make sure no sensitive customer data ever even gets to the logging system, right?
Exactly. It's like having a privacy shield up from the moment data is created. This pattern is also perfect for companies in industries with strict regulations where data protection is a must.
Makes sense. Now, runtime passive Pdiving seems a bit more flexible. When would you want to use that one?
Runtime passive Pdiving is great if you don't want to mess with your existing systems too much. So if you've got older systems or really complex workflows that are hard to change to do real-time data transformation, runtime passive Pdiving is a gentler approach to data protection.
So like a big company with tons of interconnected systems could use runtime passive Pdiving to slowly start anonymizing data without disrupting everything.
Exactly. It's like adding in privacy measures smoothly without shaking things up too much. This pattern is also good for companies that need to balance performance and data protection. It lets you process data in batches so it doesn't slow things down as much.
Okay, and what about static Pdiving? When is that the best option?
Static Pdiving is the way to go when you're working with data that's not moving, like archived logs, old data sets, backups, anything that's not being actively generated or processed.
So if you're an auditor and you need to look at logs to make sure everything's compliant, static Pdiving would let you anonymize any sensitive info in those logs before you start looking. Okay.
Exactly. It's also really useful for companies that need to clean up large data sets every so often for security or compliance reasons. Static Pdiving can be used to remove sensitive info from databases, data warehouses, and any other place where data is stored.
So it's like a cleanup crew for data privacy, making sure that even your old data is protected, even if it wasn't handled that way before.
Yeah, that's a good way to put it.
Now, we've talked about these patterns one by one, but our sources say that the really cool thing about Pdiver is that you can combine them into hybrid solutions.
Absolutely. Hybrid approaches let you customize Pdiver to fit what you need, because different parts of your system might need different levels of protection or different ways of handling data.
So a software architect who's designing a complicated system with lots of moving parts and data flowing everywhere, could they use runtime active Pdiving for some really important parts? Runtime passive Pdiving for others, and then every so often use static Pdiving to make sure all their data stores are cleaned up.
Exactly. It's all about creating layers of data privacy, using the right tool at the right time for each step of the data lifecycle.
That's amazing. It shows how flexible and adaptable Pdiver is as a solution for data privacy.
And it lets companies think about data privacy in a complete way, making sure sensitive info is protected everywhere it goes from the moment it's created to wherever it ends up stored.
So as we wrap up this deep dive, I think the big takeaway is that Pdiver is more than just a tool. It's a way of thinking, realizing that data privacy has to be built into our systems from the very start.
Yeah, I totally agree. It's about moving past the idea of data privacy as something you add on later, and instead making it a core part of how we develop software.
And with tools like Pdiver, we can actually make that happen.
Exactly. Tools like Pdiver give software designers, architects, security people, and auditors what they need to work together and build systems that are both secure and protect privacy.
So as you go back to your work, we encourage you to think about how Pdiver can help you deal with the challenges of data privacy and build systems that protect sensitive info without sacrificing how well they work or how fast they are.
And remember, data privacy isn't just about checking a box on a compliance form. It's a fundamental part of building systems that people can trust and that are responsible. It's about respecting user privacy, keeping sensitive info safe, and making the digital world a more ethical and secure place.
Thanks for joining us for this deep dive into data privacy and Pdiver. Until next time, stay curious, keep learning, and stay safe.